Hello, students, and welcome back. Today, we're going to talk about perceptual interpretation. Perceptual interpretation. So the first thing we want to talk about today is extrasensory perception, which is a collective term for hypothetical mental abilities. I'm talking about things like telepathy, clairvoyance, precognition, telekinesis. Here's the thing. None of this has been proven by science. Every person who claims to have these abilities unfortunately has never been able to demonstrate them under carefully controlled laboratory conditions. That doesn't mean that someday this might change, but as of right now, not so much. Sorry. One interesting condition, however, is known as synesthesia. And synesthesia is a cross-wiring in the brain where basically one sensation produces multiple perceptions. So for example, being able to see sounds or hear colors or taste shapes or something like that. So I thought I'd show you an example of synesthesia right now. So for some forms of synesthesia, the person actually, when they see numbers, they see them as different colors. So if you had synesthesia, you would have automatically noticed. Now, that doesn't mean you wouldn't have seen this before if you looked at it long enough to notice that a few of them were backwards. But if you see these as colors, it would have stood out to you immediately right away. Isn't it beautiful in the spring? Read the sentence. Really read the sentence. You see it now? So the error is the. This is the perceptual set. A perceptual set is our tendency to perceive or notice some aspects of available data while ignoring others. It's also known as perceptual expectancy. So if you're looking here at the image on the bottom, you could have perceived this as ABC, if that was all you saw, or 12, 13, 14, because our perception changes depending on expectations and information surrounding what we're seeing. So we're going to watch a short video about this now. A perceptual schema is our internal representation of an object, which is acquired through perception. This often determines our perceptual set. For example, we're really good at seeing right side up faces, but we have a difficulty when the face is upside down. So you may notice maybe something's off about Adele's face, but what is it? It has to do with the fact that her eyes were upside down and her mouth is upside down as well. Okay, but it looks relatively normal to us. Human factor psychology. So human factor psychology is basically the interaction between people and technology. So if we look at this image here, you'll see two stoves. Now, your first instinct might be to say, oh, I really want the stove on the right, which totally makes sense. It's chrome, it's got more burners, it's a nice stove. But there's a problem with that stove. Notice where the knobs to turn the burners on and off are located. Might be kind of a bad place if you don't like burning your hands. Okay, so human factor psychology actually started with cockpit design because people they were designing jets and the pilots kept crashing them and they couldn't figure out why. So it had to do actually with the location of the joystick to navigate the plane. It was actually located higher up, which made it more difficult to push other buttons and things like that, and why people were crashing. So really, you don't notice human factor psychology, you just notice bad design, which is kind of important to note. Context effects. So a context effect is when a single stimulus triggers different perceptions based on surrounding context. So we're going to watch a short little video about the cat right now. And then the last thing is perceptual adaptation. Perceptual adaptation is basically our ability to adjust to change sensations. So for example, they did an experiment on this, which is really cool, where they had individuals wear special goggles that took everything and flipped the image upside down for them. So the interesting thing was after, it varied a little bit in terms of the individual, but after a period of time, what was the world that was upside down, suddenly the brain flipped it to being right side up, and they were able to do everything just like they would normally. But the really cool thing is when they took the goggles off, their world was actually upside down. And it took, I mean, it usually no longer than an hour before the brain flipped everything right side up. So basically, the reason why we see the world the way that we do is about gravity. And it's just our brain has been like, this is the way things would be. But I wonder what it would be like if we grew up in an environment where that was no gravity or low gravity. Would we be better at perceiving things upside down? Who knows? And that, ladies and gentlemen, is all I have for you today. If you have any questions, let me know. Otherwise, have a fantastic day.